parallel perpendicular lines. So, aside from the fact that you should have your little book out, your notes, your headphones off, David, we've dealt with these things before. Parallel lines, perpendicular lines. The thing that we must remember is that they are opposite reciprocals when it comes to the slopes. You multiply the two slopes together, you get a -1. Ways of telling. So, my question starts off here is, are these parallel? Now, we can't just go and look at them and say, yes, they are. We actually have to go through and take a look at some things on them. Slope. Now, there's different ways of looking at this. We can take the coordinates, and you guys remember what that is. y2 minus y1 over x2 minus x1. That's one way of doing it if we are just given the coordinates. Now, another way that we could do this is simply go and count how far up or down we have to go, but always moving to the right. So because these are moving to the right and up, we know we got a positive slope. So let's try counting them out once, see if that works. This goes up 1, 2, 3, 4, 5, 6. So I got 6 up, and it looks like I have to go over 1, 2. So this would have a slope. Now again, our slope can be rise over run, always going to the right. Up is positive, down is negative. So by looking at this one, I see that we've got 6 over 2, which would work out to be 3 over 1, or just 3. Good. Now, what about the other one? Well, point here, point there. I have to go up 1, 2, 3, and over 1. So that one has a slope of 3 over 1, which is just 3. So, based upon what I see there, do I have parallel lines? Slopes are the same. And like I said, it all depends upon what you see, what's easiest for you to go through and identify based upon the information that you have. So, make sense? Yes, no, maybe so. Righty? Are these perpendicular? Well, do they look like they're perpendicular? Can I use looks to go and take care of anything on this? The answer is no, we have to verify. Okay, so rather than going and counting it up, let's go and take care of this one by the coordinates. So let's start off here with this line. Call this my first point, call that my second point. So for our y2, we would have 5 minus -1 over 2 minus -1, right? y2 minus y1, y2 minus y1, x2 minus x1, plus 6, plus 3. So that means that we have a slope here of 2 over 1, or just 2. Now, if we have perpendicular lines, I would expect to see -1/2, opposite and reciprocal. So we're going to call this point 1. We'll call this point 2. So y2 is 2 minus y1, which is 4, over x2, which is 2, minus y or x1, which is -2. So This turns out to be plus plus, and I end up with 4 on the bottom. Here I get negative 2. This simplifies down to negative 1 over 2. So, are these perpendicular lines? And yes, we have verified that they are perpendicular lines. But again, we need to make sure that we go through and take that kind of information on it so that we can verify and state for certain. All right. Writing equations of parallel and perpendicular lines. Now, I want an equation that is parallel. Well, first offhand, I need to know where the slope is. Since we've got the equation y is equal to mx plus b, slope is right there, correct? So there is one other formula that I need to remember as well, and that's point slope form. We've talked about this one before, wrote it down, but again, it is y minus y1 is equal to m times x minus x1. So we're going to start off here. Y, need that, minus y1. Well, it's supposed to go through the point that is right here at 3, 2. So y minus 3 going to be equal to, what's my slope? Well, the slope has to be right there, so we know that's going to be 3. X minus x1, which is 2. Plug the bits and pieces in, see where they go. So now I have y minus 3, and put it up over here. Y minus 3 is equal to 3x minus 6, add 3, and our equation is y is equal to 3x minus 3. So this is going to be a line that is parallel to the first one, same slope, and goes through the point at negative 2 or at 2, 3. And if we wanted to check that, what is 3 times x, which is 2? What's 3 times 2? 6. What's 6 minus 3? 3. What's supposed to be y? 3. So it did work. Okay. Now we're supposed to find the equation of a line that passes through the point negative 1, 3 and is perpendicular. Okay. So again, we need to take a look at the slope. Well, it has a slope right here of negative 0.5. This is part of the reason why we try and avoid decimals at all costs. Most of this stuff works in terms of fractions. So what is negative 0.5 as a fraction? So I got negative 1/2. So what's its perpendicular slope going to be? Well, opposite, if it's negative, it's got to be positive. Reciprocal would be 2 over 1 or just 2. So I know that the slope that I have to use is 2. So here we go again. Y minus. Well, what's y1? Y1 comes from here over here, and it's going to be 3. Slope. Slope is 2. X minus, what's x1? X1 is negative 1. Okay, and there we go. Work it out. Well, we know this is going to be plus plus. So we get y minus 3 is equal to 2x plus 2. And so it looks like I have to add 3 to both sides, add 3 to both sides. So y is equal to 2x plus 5. Once you get into the habit of writing it all out, doing the process, it kind of goes naturally. You keep looking for specific things, and as long as you look for those things, you'll be okay. Questions on that? Are these two lines parallel? Now, I showed you a trick I'm thinking a while back. When we have things in standard form, looks like AX plus DY is equal to C. I do believe I have mentioned that the slope is going to be equal to negative A over B. We've talked about this one, haven't we? Remember it? This is a very handy one for this type of a problem. Why? All I got to do is pick and choose. I know it's got to be negative. What's A? A is 5. What's B? B is 3. So this slope is negative 5/3. Pulled that out right away. Didn't have a problem with it. So X and Y is in the right spot. So we take a look at this one. I need a negative. I need A. A is 15. B is 9. Well, this would simplify by 3's to negative 5 over 3. So what are these to each other? Are they perpendicular or are they parallel? They would end up having to be parallel because the slope is the same. Easy enough? And if you know these little tricks, these little shortcuts, it's nice. Otherwise, you end up having to create it, put it into slope-intercept form, go through, plug in a bunch of values, come up with an XY chart, graph the line if you have to do it that way, and then look at that. Or by slope-intercept form, you'd have the line there with the slope. All depends upon what you see. Now, when I take a look at something like this, all I have are coordinates. Now it tells me that A, B, and C are collinear. So this group here should be on one line. This group over here should be on another line. Now, we're supposed to compare the equations of the lines through those sets of points. So I got to come up with the equation. First offhand, does it matter which points I choose? Should it matter which points I choose? No. Choose whatever points that I want. So we are going to take and first figure out what is the slope. So we are going to take 5.5, sorry, 5.5 minus 5 over 3 minus 1. So that's my 2, that's my 1. So it looks like I end up with 5 over 2 for a slope, correct? So let's see. I want to pick easy numbers to work with. I'm going to pick on this one over here because I got this denominator of 2, and I know that they can cancel out over here. So we'll try that and see if that works. Y minus Y1, 8, is equal to 5 over 2 times X minus 4. Y minus 8 is equal to 5 over 2x. Now when I multiply here, 2 cancels with the 4. I get a 2. 2 times 5 is 10. Add 8. Add 8. There. Now again, we're doing and repeating so much of the same stuff. So pick on points again. Doesn't really matter which ones I do, so I'll take E and F. That'll be my 1, that'll be my 2. So I'm going to call that to be negative 0.9 minus negative 0.1 over 6 minus 4. So it looks like plus plus, so it looks like I have negative 0.8 over 2, right? Now, decimals and numbers, yuck. Can I easily change this and get rid of those decimals? What could I do to do that? Could I just say, you know what, I want to put the decimal point here and call this negative 8? And could I do the same thing over here, move it over 1 and call this 20? Okay. So if I simplify this down, this looks like it's going to be negative 2 over 5. So have I just figured something out between these two lines? Do I notice something? Hope so. I got this, and I got that. So are they perpendicular to each other? Okay. So now we go through, do the rest of it. Y minus. Unfortunately, there just isn't a nice and easy way of dealing with this, so I'm just going to use y minus, we'll go 0.7 here, is equal to the slope, which is negative 2/5 multiplied x minus 2. Okay. So that means I got y minus 0.7 is equal to negative 2/5 x minus nothing I can really do here nicely, so that's going to be 4/5. Now, one of the nice things about this, if I got 4/5, could I easily play with decimals here, or shouldn't I? What should I do? You want decimals or fractions? What you think? Decimals or fractions? You like fractions, okay. So how about I go and change this then to y minus 7 over 10 is equal to, good common denominators all the way around, because I get that eventually, negative 2/5 x minus, say, 4/5. Add 7 over 10, 7 over 10. Y is equal to negative 2/5 x. Well, this would have to be 20 over 10. No, it wouldn't be. 8 over 10, which would get me down to 15 over 10. Y is equal to negative 2/5 x. Ooh, did I screw up? What about my signs? Positive and negative. Terrible, terrible, terrible. Gotta watch those signs. Minus 1 over 10. So there we go. Now I realize that this is extremely tedious work for you guys, but you need to be able to do it. Is there a faster way? You want to see a faster way? You know how to use your graphing calculator? If I were to go and put these 3 coordinates into the graphing calculator, do you know how to get the equation? I put these in there. Do you know how to get the equation? Well, let's walk through it real quick just to make sure that you've got it. Second plus 712. Oh, and I've learned a new trick when it comes to the graphing calculator. I'll have to show you what it is. So Here we go. Stat. Edit. Put in our numbers. We got 1, 3, 4. I would recommend putting all of them in just so that you make sure that things are correct. So I've got 0.5, 5.5, and 8. Enter. So I've put all the ones for the red ones in, right? Now we press Stat, Calc, and number 4. Yes. Enter. So I have my equation. It says A is equal to 2.5, and then I get negative 2. By the way, if I take 5 over 2, is that 2.5? Minus 2. Now I said I learned a new trick. I've got it written down on the second whiteboard over there. Rather than having to go through and retype all of this in, you can actually go and copy it. I knew you could do it, I just hadn't played with it. So what I want you to do, press the Y equals key. That's the equation we want, correct? So the instructions are now, hit the vars key. If you don't know where it is, find 9, find the parenthesis, tangent, bars. So you press the vars key, then it says number 5, statistics. So we press 5. Go over to where it says EQ, equation, press enter. It just copied the entire equation over. Okay, so here we go. Next one. Press Stat. Now we're going to edit. And we're going to put this data in for those of you that aren't paying attention. So I am going to put in 2, 4, 6. Up here, 0.7, negative 0.1, negative 0.9. Okay. If you know how to use the calculator and can do it, I would rather see you do it this way, especially when it comes to the MCA stuff and the ACT. Accuracy versus speed. If you know how to do it manually and can do it fast, see the tricks, good. Otherwise, put it into the calculator and go through and do it this way. So now, I've got my data in. I want the equation. Press the Stat key, Calc, number 4. So I've got those identified, and I press Enter again. So now let's put in the new equation. So let's see. Did it work out for me? Let's see, 2/5. Oh yeah, that'd be negative 0.4. Ooh, 1.5, 10. Something I messed up there, didn't I? Let's see, where would have I messed up? Oh, I see where I messed up. What's a negative times a negative? Positive. So that means that, better clean this up while I'm seeing it. Negative times a negative would have been a positive. That would have been a positive. That means that this would have been plus 15 over 10, which would have been, 3 over 2. Even I make mistakes when I sit there and I go through this. That's why I keep telling you. Always double check your work and show your work. So there's my equations. Now, we want to put this into the calculator. Y equals, we are going to go down to Y2. So arrow key down, so that you're flashing at Y2. Everybody know where the vars key is now? So press the vars key. Press 5 for statistics. Press enter. Go over to EQ. Press enter. There's that equation. Now, if I go through and graph, there's our equations, and there they go. So I can see them. And then even if you want, you could do second y equals, turn your plots on, but you'd only get some of the ones that are there. You wouldn't get both sets. You'd have to go and do a little bit more work there, so I'm not going to go through that. So there we go. So what are they? Well, do they appear to be perpendicular on the graphing calculator? Sort of, kind of. Got to remember, the graphing calculator isn't a nice square. It's a rectangle. So it'll be off a little bit. But the thing that we really wanted to look for was these two equations, or these two slopes, I should say. So how about finding the equation of horizontal and vertical lines? So if I have an equation that is y is equal to 2, what kind of an equate or a line is that going to be, horizontal or vertical? When in doubt, let's see, if I remember correctly, this is the y-axis, this is the x-axis, yes? I am looking for y equal what? Y-axis 2 is right there. So it looks like it would have to be a line that would go through here. Okay. So there's my line. And now I want to find the line perpendicular to it that goes through 4, -1. Let's see, where's 4? 1, 2, 3, 4, -1. Right there. So if I want it to be perpendicular, it would have to go up like that. Yes? So where is it going through the y-axis at? Correction, x-axis at? So because I had to go over 1, 2, 3, 4, the equation is right there. X is equal to 4. So if it needs to be perpendicular, all I have to do is identify the other. If it's y, then I got to look at x. If it's x, then I got to look at y. Let's try this one. I want it to go through where x is equal to 15. So x equal 15, that's going to be 1, 2, 3, 5, 10, 15. It's going to be right here. So it's going to follow this line up here. And it's got to go through the point 7, 1. So it's 5, 6, 7, -1, which is right there. And if I want a perpendicular for it, that means it's got to go this way across, correct? So that means I grab this point here and I say y is equal to -1. That's the equation. Okay. Easy enough? Okay. Right triangles. Is that a right triangle? Doesn't look like one, but that's not what I'm going to use to figure it out. What I am going to do is I am going to take a look at it like this. I have to go up, let's see, that's at 3. So that means I've got 4, 5, 6, 7, 8. So how far did I have to go up? 1, 2, 3, 4, 5. I went up 5. And now this is going over by, yep, same thing. 1, 2, 3, 4, 5. So that's 5. So rise over run. 5 over 5, which is equal to 1. It's slope. What about this one here? Well, let's see. I have to go over 1, 2, 3, 4, 5, and I have to go down 1, 2, 3, 4, 5. But that's a -5. So that's 5 over -5, which is equal to -1. Are they opposite reciprocals? Are they, is it a right triangle? That's all I'd have to do if I wanted to make sure that I had a right angle on there. That's all I would need to do. So what I want you to do is I'm going to give you a couple of minutes here and I want you to do this practice problem and see what you get. What'd you figure out? What's 4? 4. 4. 4. Okay. Good. Okay, so, well, if those are the points, these are collinear, so they're on one line. So this will be 2 and that'll be 1, so that'll be -1 minus -4 over 2 minus 1. Plus plus, I end up with 3 over 1, so I got 3. Got that slope. Now for this one here, that's 2, that's 1, so that will be 25 minus 19 over 5 minus 3. Let's see, 25 minus 19, last I checked was what, 6? Over 2, which you reduce down to 3 over 1 or 3. Yes, it wasn't that bad. Problem is, 4 wouldn't even be the answer to the question. What is the question? What can I say about the lines that cross these points? They're parallel. That's okay. Not a problem. So here's another pair. See what you can say about it. Eli does not have the answer. Oh. So here we go. Well, rather than volunteering, I suppose what I could do is we'll pick on somebody. Let's see, who's number 11? Micah's number 11. 6. But does that answer the question? What do you think the answer is? How do you know that, Mr. Thibodeau? Yeah. You're making an assumption, huh? Hypothesis. Well, and we're going to test that. So that's going to be 16.63 minus 16.88 over 3 minus 1. Writing down the numbers is simple. So what is that when you subtract the two? Well, I suppose you could just use your calculator. 16.63 minus 16.88, which is what I would do instead of complaining about things. So that's going to give me a negative 0.25 over what? 2. Now that's ugly. Divide that by 2, what do I come up with? Negative 1.25? Ick. Does it matter? No. We're just going to leave it that way for the time being and see what we come up with when we do the next one. So that one is going to be 40 minus 24 over 4 minus 2. Well, this turns out to be what? Let's see. What's 40 minus 24? Well, that's 16, yes? Divided by what? So that's got to be 8 over 1. Okay, so I got 8. But that top one is still bothering me, isn't it? Well, let's see. What happens if I move the decimal point over 2 places, 2 places? That'll be 25 over 200. Let's see, how many 25s are in 200? Negative 1 over 8. How many 25? How many quarters are in $2? Okay, so there we go. Try this one. So Mr. Thibodeau, what did you do here? Okay. Two things you need to know. One, slope, negative 13. And it has to go through this point. So that means it's y minus, what's y1? 15. Is equal to negative 13, which is our slope, x minus what is y, or x1? 0. So that means I got y minus 15 is equal to negative 13x. Add 15, add 15. Y is equal to negative 13x plus 15. There's your equation. Okay. Questions? Yeah, but Mr. Thibodeau, are you writing it out like I've got here? Well, yes, but you've got to remember, if it's negative here, it's added here. So, one more. Let's give this one a try. For a second, Mr. Thibodeau, what do you want here? Y equals plus 1. Okay, let's give her a whirl. Now, this has got to be perpendicular, correct? So, this slope is 25, so perpendicular slope is going to be negative 1 over 25. So I know what you did. I can, because you ended up subtracting 25 from 37 to get 12. That you had to. That's, let me finish. Okay. So you went y minus 37. There, that'll do it. So y minus 37 is going to be equal to negative 1 over 25x plus 1 over 25. Add 37. Add 37. So for this one, I'm going to cheat. Because I had to go perpendicular. If the slope was 25, the perpendicular slope is the opposite reciprocal. Parallel. Okay, do it at the end of class tomorrow.